The sun is dying. Slowly, predictably, and spectacularly. Right now, 4.5 billion years into its life, it sits in what astronomers call the main sequence. Balanced. Stable. Fusing around 600 million tons of hydrogen into helium every single second, in a core roughly 15 million degrees hot. That balance is temporary. In about a billion years, the sun will brighten by 10%. That sounds small. It isn't. It's enough to boil the oceans. Earth becomes Venus. The atmosphere thickens with water vapor, then strips away into space as the upper layers superheat. No more liquid water, no more life as we know it. Humanity, if it still exists, either dies or has already left. Every serious planetary scientist working on long-term habitability models agrees on this timeline, give or take a few 100 million years. In about 5 billion years, the real ending begins. The sun runs out of hydrogen in its core. Gravity starts winning. The core collapses, temperatures spike to roughly 100 million degrees, and helium fusion kicks on while the outer layers swell outward in a panic of thermal energy. This is the red giant phase. The sun will bloat to roughly 200 times its current size. It will swallow Mercury within minutes on a cosmic scale. It will swallow Venus next. Earth's fate is debated. Some models say Earth gets consumed around the 6 billion year mark. Others say our planet spirals outward just far enough to survive the expansion, scorched but intact, a dead cinder orbiting a monstrous red star that fills half the visible sky. Either way, life ends long before. Here's the wild part. The red giant phase is chaotic. The sun will pulse. It will shed enormous amounts of mass into space in slow, graceful waves of glowing gas, losing maybe half its total mass over a few 100,000 years. From a safe distance, it would be the most beautiful thing any being ever saw. Imagine a burning pearl, pulsing once every few thousand years, each breath painting new shells of light into the surrounding darkness. The entire outer atmosphere of the sun will slowly drift away, forming a planetary nebula. Those lovely glowing cloud pictures you've seen from Hubble and the James Webb Space Telescope? Many of them are dying stars from another galaxy, in exactly this phase. Our sun will make its own, visible for about 20,000 years from any observer within a few hundred light years. After the outer layers are gone, only the core remains. Collapsed. Dense. Roughly Earth-sized but weighing almost as much as the original sun. A teaspoon of this material would weigh several tons. This is a white dwarf. A diamond-cold ember, slowly cooling over trillions of years. It does not explode. Our sun is not big enough to go supernova. It just fades. Here is the part that stops me every time. In the final stages, the white dwarf will crystallize. Carbon and oxygen in a near-perfect lattice. An entire star the size of a planet, slowly turning into something we don't quite have a good word for. Astronomers recently confirmed this crystallization is already happening in older white dwarfs across our galaxy, using data from the Gaia mission around 2019. Black dwarfs, we call them, though the universe isn't actually old enough yet for any to have fully formed. The cooling process takes longer than the current age of the cosmos. Could anything we built survive this? A civilization a few billion years more advanced than ours could theoretically move planets or build structures around the dying sun. Physicists actually have the math for it. You nudge Earth outward with repeated gravitational slingshots from a captured asteroid. You dim the expanding star with a solar shade 1 million kilometers across. Whether anyone does, we'll never know. Here's what I want you to sit with. Every warm afternoon. Every sunset. Every sunrise. You are inside a nuclear reaction 8 minutes of light away, burning at a steady pace, 4.6 billion years in. It will keep going long after we're gone. But not forever. Nothing does. Look up tomorrow. Really look. The thing you are glancing at is a slow, enormous, gorgeous death, and you are walking around inside the best phase it will ever have. Here's one final thought worth sitting with. Every carbon atom in your body was forged inside a dying star long before our sun existed. You are, quite literally, the recycled fuel of a previous generation of suns. When ours eventually fades, the heavy elements it makes will drift for billions of years and seed whatever comes next. New stars, new planets, maybe new forms of curiosity looking up the way you are right now. The universe's preferred art form isn't stillness. It's transformation, written in light, on timescales our brains were never built to hold. And we get to witness a small, bright chapter of it.